Picture a revolver, but the cylinder doesn't have 6 chambers. It has 100 billion, and only one allows you to survive. All the others are fatal. You spin the cylinder. You take the risk. The hammer falls. You are alive. Your first thought is, I am lucky. But cold mathematics will tell you the truth. You are not lucky. You are a statistical error. We have been fed a lie that the universe is a friendly ocean. Today, we destroy that illusion. Space is not an ocean. It is a complex machine designed to kill, and we are the anomaly that broke the mechanism. You step into a massive banquet hall. Everything is ready for the celebration. The tables are groaning under the weight of food. Music is playing, and wine glasses are full. But there is one catch. The hall is empty. You are alone. You shout, "Hey!" but your echo just dies in the velvet of empty chairs. Your first instinct isn't loneliness. It is fear, because if the table is set but the guests are missing, something must have happened to them on the way. This isn't a scene from a horror movie. This is an exact description of our position in the Milky Way. We are used to looking at the stars with romantic awe, but if you apply cold logic, the night sky should terrify you. The Drake equation, that sacred cow of astrophysics, has convinced us for decades that the universe is teeming with life. Multiply the number of stars by the number of planets, add time, and you get millions of civilizations. So, where are they? The silence of space is the loudest sound in the universe, and today we stop comforting ourselves with hope. We are going to face the facts that suggest we aren't here because it's normal. We are here because we are a survivor's error. For a long time, we were taught the so-called mediocrity principle. The gist is simple. Earth is an average planet, orbiting an average star in a backwater arm of an average galaxy. Carl Sagan and Iosif Shklovsky taught us humility. We aren't the center of creation. We are cosmic dust, a statistical average. This principle became the foundation of modern science. It's convenient. It's comforting. It says, if it happened here, it will happen elsewhere. But there is a problem. A layer of facts suggests that this principle is a lie. In 2000, paleontologist Peter Ward and astronomer Donald Brownlee published a book that sounded like a death sentence to many. They took the Copernican principle and smashed it against the rocks of geology and astrophysics. Their thesis, known as the rare earth hypothesis, is brutal. Simple life, bacteria, might be everywhere in the universe, but complex life, animals, plants, us, is the result of a chain of circumstances so rare that we might be the only ones within millions of light years. Let's strip away the romance and look at our galaxy as an engineering structure. Most people imagine a galaxy as a uniform disk sprinkled with stars. This is a mistake. A galaxy is a city with strict zoning laws. The center of the Milky Way is a death zone. The stellar density is so high that the night sky would burn brighter than our day. But the problem isn't light, it's radiation. Supernovae explode there with frightening frequency, sterilizing everything with hard gamma rays. Living in the galactic center is like building a kindergarten inside the Chernobyl reactor. Okay, you say let's move to the suburbs, to the quiet countryside of the galactic disk. But here we hit a dead end. On the outskirts, stars lack metals. Astrophysics shorthand for any element heavier than helium, carbon, oxygen, iron, silicon, the building blocks of terrestrial planets. Out on the periphery, the universe is too clean. Only gas giants are born there, useless balls of hydrogen. There is simply nothing to build a solid planet with. Make no mistake, there is only a narrow ring, the galactic habitable zone, a thin slice between the radioactive hell of the center and the resource famine of the outskirts. And our sun sits right in this Goldilocks zone. But even landing in this zone doesn't guarantee life. The galaxy rotates. It has spiral arms, those beautiful glowing blades we see in photos. We tend to think of them as static structures. In reality, spiral arms are density waves. They are giant cosmic meat grinders. Inside the arms, massive stars are born and die, creating zones of colossal turbulence and radiation. For any star system, crossing a spiral arm is a climatic and biological catastrophe. Every entry into an arm raises the risk of a nearby supernova or a collision with a giant molecular cloud that could strip a planet's atmosphere. And this is where the real magic of numbers begins, or if you prefer, the devil's own luck. The orbital speed of stars depends on their distance from the galactic center. The rotation speed of the spiral arms does too. In most cases, these speeds don't match. Stars constantly crash into the arms and fly out of them, undergoing regular sterilization. But the sun is special. We are located on the so-called co-rotation circle. Our speed around the galactic center is almost perfectly synchronized with the rotation of the arms themselves. Imagine a surfer on a giant wave. If he swims too fast, he falls down the face. If he's too slow, the wave crashes over him, grinding him into the ocean floor. The sun is a surfer that has kept its balance for 4.5 billion years. We exist in the void, between two deadly arms, Perseus and Sagittarius. We don't cross them, we surf between them. With a degree of caution, we can assume this factor was decisive. Earth had time. We had billions of years of quiet evolution, while other worlds burned in the furnaces of the spiral arms. We won a lottery where the odds of winning trend towards zero simply by picking the right parking spot in the galactic metropolis. A skeptic will say, but we are here, so it must be possible. This is a classic survivorship bias known as the anthropic principle. We observe these conditions not because they are common. We observe them because if they didn't exist, there would be no one to do the observing. The fact that you hit the jackpot doesn't make the lottery a profitable business for everyone else. However, finding the perfect spot in the galaxy is just the beginning. The survival of a star system isn't just a navigation problem. It is also a question of interior architecture, because the greatest threat to life on Earth didn't come from deep space. We used to consider our solar system the gold standard of order, small rocky planets near the star, giants on the outside, a perfect clockwork mechanism. But when we started discovering exoplanets, astronomers were shocked. It turned out our system isn't the rule. It is an ugly anomaly. Normally, gas giants act like crazed bulldozers, destroying everything in their path. Why didn't our Jupiter kill us in the cradle? The answer lies in an event that nearly destroyed the Earth, but instead gave us life. When we first discovered a planet around another star in 1995, astronomers were speechless. We expected to see a copy of our system, small, rocky planets close to the warmth, gas giants on the cold periphery. But the universe laughed in our faces. The first worlds discovered were hot Jupiters, gas monsters orbiting so close to their stars that a year lasts only a few days, and their atmospheres boil off into space. This discovery overturned everything. It turns out planets don't stay where they are born. They migrate. Gas giants, born in the outer system, begin a spiral death march toward the star, acting like cosmic bulldozers. Along the way, they gravitationally eject all Earth-like rocky planets into deep space, or feed them to the star's furnace. Without a doubt, our solar system is a disaster survivor. Simulations show that Jupiter also began its deadly march toward the Sun. It should have destroyed Mars, Earth, and Venus before they were even born. But a miracle happened. Saturn, the second giant, formed just in time, and its gravity pulled Jupiter back, locking it into a safe orbit. This gravitational dance of two giants saved the inner solar system. We are alive only because Jupiter had a leash called Saturn. But Jupiter's role in our fate is far more controversial than usually portrayed. Popular science books often say Jupiter is our big brother. Its gravity sucks up comets and asteroids, protecting Earth. George Wetherill proposed this idea in the 90s. It's a beautiful theory, but computer simulations by Horner and Jones in 2008 revealed a frightening underside. Yes, Jupiter takes some hits. Remember Comet Shoemaker-Levy 9. But it also acts as a catapult. With its immense gravity, it rips calm asteroids from their orbits and hurls them into the inner system. Without Jupiter, the impact frequency on Earth would be lower, but without it, we wouldn't have water. It was this bombardment, organized by Jupiter in the early stages, that delivered icy comets to a dry, scorched Earth. Our oceans are melted snowballs thrown at us by a giant gas ball. Jupiter isn't a kind big brother. It's a deranged neighbor with a shotgun who shoots out your windows occasionally, but once a year throws a bag of cash into your living room. However, even water doesn't make a planet alive. To become a cradle, Earth had to be killed first. Imagine an impact so powerful the planet turns into a ball of plasma. The crust evaporates, rocks rain from the sky, and the firmament becomes an ocean of lava thousands of kilometers deep. This isn't the end of the world. This is our world's birthday. 4.5 billion years ago, Earth collided with a protoplanet the size of Mars. Theia. It wasn't just a cosmic fender bender, it was a merger. Theia's core sank into Earth's depths, fusing with our own, while the ejected debris formed the moon. Why do we need the moon? For romance? No, without the moon, life on Earth would likely be impossible. Look at Mars. Its axis wobbles chaotically from 10 to 60 degrees. This leads to monstrous climate shifts. Glaciers grow at the equator, then vanish. Stable climate is impossible there. Earth, however, is tilted at 23.5 degrees and holds that tilt with an iron grip. Why? Because the moon acts as a massive gravitational anchor. It stabilizes our rotation. Seasons, predictable climate, cycles. These are all gifts from the moon. We aren't just the third rock from the sun. We are a double planet system, unique in our galaxy. But Theia's greatest gift was hidden deep beneath our feet. The collision superheated Earth's core and added mass to it. We gained a giant, furiously spinning iron generator, a magnetic field. This is our invisible force field. Without it, the solar wind, a stream of charged particles flying at 400 kilometers per second, would simply strip away our atmosphere. Look at Mars. It lost its magnetic field, and the sun flayed it alive, leaving a thin, lifeless shell instead of air. We are alive because an ocean of molten metal rages inside our planet. Moreover, the Theia impact likely kickstarted plate tectonics. Earth is the only planet we know of whose crust consists of moving fragments. Why is this necessary? It's climate control. Volcanoes spew CO2, warming the planet. Rain washes CO2 out of the atmosphere, binding it in rocks. Plates drag these rocks back into the mantle, where they melt and are spewed out by volcanoes again. This cycle has regulated the temperature for billions of years. If it gets too hot, the cooling mechanism speeds up. If it gets cold, it slows down. Venus is dead because it has no tectonics, carbon accumulated in the atmosphere, turning the planet into a hellish oven. Mars is dead because its tectonics stopped and it froze. Earth is an incredibly complex electromechanical device. To make it work required a perfect star, protection from galactic radiation, precise orbital calibration by Jupiter, a chance collision with another planet to create the moon, and the ignition of a magnetic field. The probability of all these factors coinciding, statistically negligible. It would seem the stage is set, the props are in place, the lights are on, the temperature is comfortable, the shields are up. In the oceans, the primordial soup, a mix of water and chemicals, is simmering. All that's left is to add the final detail, life itself. Many think that if you have water and heat, life will arise automatically. Just wait 1 million years, and chemistry will turn into biology. This is the greatest lie in the history of science. Between dead matter and a living cell lies not just a step. There lies an abyss that, according to the laws of physics, is practically impossible to cross. And the story of how we jumped over that abyss makes even atheists feel a chill down their spine. Take a box containing all the parts of a Boeing 747. Throw it into the air. What is the probability that upon hitting the ground, the parts will assemble themselves into a flight-ready airliner? Sir Fred Hoyle, the British astronomer, argued that the probability of life spontaneously emerging is roughly the same. We are used to thinking that evolution is an escalator inevitably carrying matter upward, from atoms to molecules, from molecules to cells, from cells to humans. This is a pleasant illusion. In reality, the universe tends toward chaos, not order. Life is a rebellion against entropy. Evolutionary biologist Eugene Koonin offers some sobering mathematics in his book, The Logic of Chance. For RNA molecules to randomly assemble into a simple replication system capable of copying itself, you would need to cycle through so many combinations that the probability is roughly 1 in 10 to the power of 1018. To give you a sense of scale, the number of atoms in the entire visible universe is only 10 to the power of 80. This means that statistically, life should not have arisen even once in the entire history of the universe. The fact that we are here is not a rule. It is a monstrous statistical anomaly. We won at a roulette wheel that had more slots than there are stars in the sky. But let's assume a miracle happened. The primordial soup came alive. Bacteria appeared. And here we hit the second, even more terrifying barrier that school textbooks keep quiet about. If life strives for complexity, why did Earth tread water for almost 2 billion years? For 2 billion years, the planet was inhabited only by bacteria and archaea, primitive slime. They didn't build cities, didn't grow eyes, didn't write poetry. They just divided. Evolution got stuck. Life hit a glass ceiling. According to the mediocrity principle, this barrier should be easy to cross, but the facts say otherwise. Complex life, eukaryotes, arose on Earth exactly once. In biology, there is an event comparable to the Big Bang. Nick Lane calls it the Great Endosymbiosis. One day, completely by accident, one simple cell, an archaean, swallowed another, a bacterium. But instead of digesting it, as had happened trillions of times before, they formed an alliance. The swallowed bacterium became the mitochondrion, the power plant inside the cell. Why does this matter? Without mitochondria, a cell cannot get big. Bacteria are limited by their membrane. To get more energy, they need to increase their surface area, but then they lose structural integrity. It is a physical dead end. Mitochondria act like internal nuclear reactors. They gave the cell 100,000 times more energy per genome. This allowed us to have vast amounts of DNA, build complex bodies, and grow brains. Undoubtedly, this event was a fluke. It didn't repeat. All plants, animals, fungi, and you are descendants of that single pair of cells that made a deal 2 billion years ago. If that hadn't happened, Earth would still be covered in green slime, and no one would be asking questions on YouTube. But even having a complex cell is no guarantee of animals. To force life to evolve further, the universe had to apply torture. About 700 million years ago, Earth froze completely. The ice sheets met at the equator. The planet turned into a white ball reflecting sunlight into space. It seemed like the end, but it was in this icy hell, in narrow strips of meltwater near volcanoes, that life underwent the most brutal selection. And when the volcanoes finally melted the ice and saturated the ocean with oxygen and nutrients, the Cambrian explosion occurred. In a short period by geological standards, the ancestors of all modern animal types appeared. Eyes, skeletons, jaws, predators, and prey. This leads to a frightening thought. Comfort is the enemy of evolution. In stable conditions, like on Venus or Mars in their prime, life can remain primitive forever. Only catastrophes that push a species to the brink of extinction force biology to find radically new solutions. We are the children of ice ages and volcanic winters. We are the result of survival, not prosperity. And here we approach the main myth of science fiction. We believe that intelligence is the pinnacle of evolution, that any life, given time, will invent radio and build a starship. Charles Lineweaver destroys this hope with one phrase: dolphins are smart, but they don't build radio telescopes. Evolution has no goal. It has no plan to create a human. Its only goal is to pass on genes. If becoming dumber helps achieve that, a species will degrade, like parasites that lost eyes and limbs. Being smart is expensive. The brain consumes 20% of the body's energy while weighing only 2%. In the wild, this is an unaffordable luxury. A huge brain makes childbirth deadly and childhood long and helpless. From a pure Darwinian perspective, high intelligence is a dubious mutation that is more likely to lead to extinction than success. Dinosaurs ruled the planet for 160 million years without any civilization. We have been here for just 200,000 years, and we are already on the brink of self-destruction. We pass through the filters of cosmic radiation, planetary architecture, impossible biochemistry, and climatic hell. We stand at the top of a pyramid of accidents, and we look into the sky, expecting to see other winners there. But what if the emptiness around us isn't a sign that they haven't arrived yet? What if this silence is the answer to the question we are afraid to ask out loud? There is one final filter, one that might not be in the past, but right in front of us, and its nature is tied to the very definition of what we call intelligence. Have you ever wondered why archaeologists find so many dinosaur bones, but so few traces of ancient civilizations? Because bones turn to stone, but cities turn to dust. We measure the age of the universe in billions of years, but the age of our technological civilization, radio and spaceflight, is barely 100 years. If you imagine Earth's history as a 24-hour day, humanity has existed for the last 2 seconds, and our ability to send signals into space is a fraction of a millisecond, a flash easily missed if you blink. In the Drake equation, there is a final variable, L, the average lifespan of a technological civilization. This is the scariest number in astrophysics. If civilizations live for millions of years, the galaxy should be colonized. If we see no one, it means L trends toward 0. This suggests that intelligence is not an evolutionary advantage, but a self-destruct mechanism. Perhaps, as soon as a species unlocks atomic energy and artificial intelligence, it starts a countdown timer. The great futurologist Stanislaw Lem, in Summa Technologiae, proposed a thesis that sounds like a prophecy today. He suggested that the technological phase of development is not an endless ascent, but a brief and turbulent crisis. A civilization grows exponentially, devouring its planet's resources and accumulating thermal waste, entropy. Either it burns up in its own fire, war, ecological collapse, or it enters a state of homeostasis, turning inward, retreating into virtual worlds, or changing its physical form, becoming invisible to our primitive radio telescopes. We search the sky for radio waves and megastructures, Dyson spheres, because that is what we are doing right now. But looking for a super civilization via radio signals is like standing in a modern office trying to find Native Americans by listening for tom-toms. Here we fall into the trap of our own perception. David Darling, in his book Life Everywhere, criticizes our obsession with doubles. We look for planets with a temperature of 20 degrees, liquid water, and oxygen. This is called carbon chauvinism. We deny the universe any imagination. Why did we decide that intelligence must be biological? Perhaps the biological stage is just a short boot disk for creating post-biological intelligence, machine, quantum, plasma. If such entities exist, they don't need planets. They don't need water. They only need energy and matter for computation. They could live in the accretion disks of black holes or in the cold interstellar vacuum. We might be looking right at them and seeing only dust or noise. Or maybe they see us. Imagine walking through a forest. You see an anthill. Do you stop to try and explain the Pythagorean theorem to the ants? No, you are too different. You just walk past. Or if you are an entomologist, you mark the anthill with tape and write, "Do not touch, experiment in progress." Perhaps Earth is a nature reserve, a zone of silence. We aren't touched because we are still too aggressive, stupid, and unpredictable. We are savages with a nuclear club, and the Galactic Council is waiting for us to either grow up or destroy ourselves, freeing up the real estate. However, let's return to facts. The zoo hypothesis is faith, not science. Science, via Occam's razor, tells us something much more unpleasant. Robin Hanson formulated the concept of the Great Filter. It is a barrier that makes the emergence of an interstellar civilization almost impossible. There are two options for where this filter lies relative to us. Option A, the filter is behind us. The origin of life, eukaryotes, multicellularity, those were the impossible steps. We passed them. We are the chosen ones. We are the first. Option B, the filter is ahead of us. Development is easy. Civilizations arise often, but they all perish at a certain stage. And that stage is waiting for us. The layer of facts from geology and astrophysics, which we analyzed in previous parts, screams that option A is correct. A unique moon, a rare Jupiter, a galactic zone, a chain of incredible coincidences. All of this points to the filter being in our past. We pass through the eye of the needle of probability, and this leads us to a conclusion that is more terrifying than an alien invasion. If we are alone, if within a radius of billions of light years, there is no one else who can think, feel, and create, then look at your hands, look in the mirror. Do you understand who you are? Do you understand what rests on your shoulders? We are used to thinking of ourselves as insignificant mold on the surface of a small rock, but the new picture of the world flips this perspective. It turns out we aren't spectators in a crowded theater. We are the only actor on a stage lit by the spotlights of trillions of stars. And if we walk off the stage, the show ends forever. Are you ready to accept the truth about your role in this universe? Because it demands action from you. Look at this darkness. If our conclusions are correct, then in this infinite theater of shadows, there is only one small candle. That is us. Many people, upon learning the scale of the universe, fall into depression. We are just specks of dust. Nothing matters. The cosmos doesn't care. This is a position of weakness. It is a convenient nihilism that allows one to abdicate responsibility. The rare Earth hypothesis turns this logic on its head. If we are the only ones, then we are not trash. We are the most precious thing in reality. Let's conduct a thought experiment. Imagine that tomorrow humanity vanishes. An asteroid, a virus, nuclear war, it doesn't matter. What remains? Stars will continue to burn, planets will orbit, black holes will devour matter, but there will be no one to exist for. Without an observer, the universe turns into a philosophical zombie. It functions, but it is dead inside. The beauty of the Orion Nebula exists only in the moment a photon hits your retina and your brain interprets it as beauty. Without us, the universe is just a giant pile of rocks and gas obeying blind laws of physics. We are a way for the cosmos to know itself. Carl Sagan. We are the eyes of the universe. We are its consciousness. And if our eyes close, the universe goes blind forever. Physics teaches us that the natural state of matter is chaos, decay, entropy. To assemble a living cell from dead atoms, and from cells a brain capable of understanding E equals mc squared, is a violation of all probabilistic laws. It is, as Dr. Manhattan would say, a thermodynamic miracle. Each of you is a walking impossibility. The fact that you are hearing these words right now is the result of a chain of luck 13.8 billion years long. Break that chain at just one link, a slightly different angle of Thayer's impact, a slightly smaller Jupiter, a slightly cooler sun, and there would be silence here. Make no mistake, this imposes a terrifying responsibility upon us. We no longer have the right to act like children playing with matches in a library. We are the sole keepers of the fire of reason in the cold nights. Flights to Mars, colonizing the moon, searching for asteroid defense. These are not the whims of billionaires or scientific curiosity. This is an insurance policy for existence itself. Keeping all our eggs in one basket on Earth is criminal negligence in the face of eternity. A single random event could erase the only spark of reason in the Milky Way. Our task is to make life multi-planetary, not for the sake of conquering territory, but for the sake of a backup drive. We looked for gods in the heavens, hoping they would come and save us, or teach us, or at least punish us. But the sky is silent, and in that silence lies the loudest answer. There are no gods, there are no big brothers, no rescuers are coming. There is only us. We are the ancients, written about in science fiction books. We are the first civilization that must pave the roads among the stars. We are the ones who must fill this dead void with meaning. Now you know the truth. You are not mediocrity. You are not accidental mold. You are the winner of nature's most brutal lottery. You are the captain of the only ship in an ocean of emptiness. Realizing this fact changes everything. It cancels the fear of loneliness and replaces it with a sense of duty. Look at the stars tonight, not with the hope of seeing someone else, but with the pride of an owner surveying their future domain. The universe is empty. It is waiting. It is waiting for us.